Thanks for joining the webinar today, everyone. The topic we're going to discuss this morning is going to be manufacturing amputations. It's going to be a basic PowerPoint presentation, just talking through some of the OSHA initiatives, some hazard awareness for amputations, and then discussion of some resources that are available. During the webinar, the chat feature will be open, and hopefully we'll be able to answer those questions using the chat feature as they come in. For any questions that would be a little more technical or take a little additional research that's not going to be answered during the webinar, we will answer those questions and post them on the web page within a week of this presentation. So to go ahead and get started, as most of you probably are aware, prior to January of 15, OSHA did require the reporting of fatalities and hospitalizations of 3 or more employees or workers that were hospitalized off a singular incident. After January of 15, OSHA changed those requirements where you still have to report a fatality within 8 hours, but now you're also required to report a work-related hospitalization where an employee is admitted to the hospital, an amputation or a loss of an eye, and you have to do that within 24 hours. So what we're really discussing today is that amputation issue that you had to report to OSHA. And obviously, as everybody's aware, those amputations are among the most severe and disabling workplace injuries that occur today. So how does OSHA define amputation? Obviously, if we need to be cognizant of the fact if we do have an amputation, we need to report that. We need to understand what an amputation is. And OSHA defines an amputation as a traumatic loss of a body part or limb or other external body part. And it would include things such as fingertip amputations. That would be with or without bone loss, medical amputations resulting from irreparable damage, or amputations of body parts that have since been reattached. So even if the body part, once it has been amputated, the doctors are able to successfully reattach it, it's still considered an amputation for OSHA purposes and will still need to be reported. If based off of those 3 indicators, it's still unclear whether it's an amputation, you could always rely on the doctor's diagnosis of how they would define the injury. And just so you know, when that information does get reported to OSHA, that's all maintained on a database which is accessible to everyone via the OSHA webpage. So they'll provide information such as what actually occurred, the name of the establishment, and some details on the amputation itself. So you could look at the link provided in the slide there above at the OSHA.gov severe injury /index. And download the data from that. So that's available. It gets updated periodically, but that's all public information. So it's available on the OSHA webpage if you care to take a look at that. We take a look at some of the metrics. So obviously we know we need to report amputations now. So what's the data look like being reported? So if you take a look there from 2015 to 2017, this would be national data. We could see that amputations account for actually 27%. So roughly a third of all the information that's reported or amputation reports. And obviously here in Pennsylvania, which is what we're directly concerned with, we can see that Pennsylvania almost directly mirrors the national average. So national average 27%, and we can see the numbers there are fairly consistent, 2015, 2016, 2017, and obviously looks the same statistically in Pennsylvania. So roughly a third of the injury events that were reported to OSHA are amputation related. So obviously if you do report an amputation to OSHA, there's a few different things that are going to happen or could happen. Obviously one of them would be an inspection that results from that report, obviously concerned with what the cause of that amputation was, and you can also, may result in it could just be a letter or a phone call or whatever it may be, but it's going to result in some type of follow-up from OSHA enforcement regarding the cause of the amputation. There's also another way that you can have an inspection related to amputations, even if you don't have an event necessarily. There is a national emphasis program on amputations. This emphasis program is actually out on the OSHA webpage, so feel free to search it on the OSHA webpage, pull it up, take a look at it. You can see the directive number on the screenshot provided on this slide. Read through it. what they're going to do here is it's actually going to list some NEICS codes that OSHA assumes would be at a higher risk for employees having amputations based off the type of industry. So you would know if your industry code is actually included in the emphasis for amputation, where you would be subjected to more of a random type amputation audit. Then obviously another opportunity for OSHA inspection is going to be facilities where they know they've had amputation citations in the past. So there's a few different ways you can be inspected with an emphasis on amputations. So most amputation injuries actually result from fingertip injuries, and the causes of those can be widespread and involve various types of activities, various types of equipment, activities resulting from just general using of equipment, maintenance and servicing, many different ways where you could have those potential injuries occurring. So with these hazardous activities, obviously you have normal production operations, which largely that's where you're going to be focused on the machine guarding hazard. So we would have potentially an amputation where an employee was just using the machine as it was designed. There was some hazard there, and the employee suffered an injury and obviously resulted in an amputation. There's obviously a lot of other opportunities where we do have amputations hazard or see amputations resulting. And you can see with many of those, they're actually have to do with the servicing and maintenance of the equipment, which goes back to your Lockout Tagout regulations. So you have the machine guarding, which is your basic 1912 and those regulations, which we'll talk about. And then your Lockout Tagout, which is the 1910-147, either through setup, inspections, clearing of jams, lubricating, just your basic servicing and maintenance. So we have a lot of opportunities to experience an amputation injury. So in order to hopefully prevent these injuries and recognize it before we do have an amputation, what we want to do would be a hazard analysis. So there we're going to take a look at the relationship between the employee, which may be the machine operator, the maintenance technician, whoever it may be, the tasks, the tools, and the environment. So we're going to actually take a look at what the operation is, what the equipment is, see how we're interacting with it, and then hopefully identify those opportunities where we need to improve some of the machine guarding. And when you're doing that, we want to look at the routine operations, the routine tasks we perform that equipment, maybe some of the non-routine stuff where we have potentially the operators exposed, as well as maybe the non-operators. It may be somebody working on an adjacent machine. It may be somebody that's more of a maintenance person where they're not directly operating the machine, but they're just involved in the maintenance. So we have a lot of opportunities where we have people interacting with that machine through different machining processes or servicing, and we want to make sure we consider all that stuff. We're obviously also going to use that analysis to help determine and define what our Lockout Tagout procedure is going to be for that piece of equipment, which is obviously something that would be required from 1910-147. One of the biggest things you want to keep in mind when you're trying to identify those machine guarding hazards, or you want to ask yourself, could the employee be exposed? Not necessarily why would they? And this is something that commonly comes up when we're on site doing a hazard analysis, specifically looking at machine guarding or Lockout Tagout at a workplace. One of the things we may ask the operator or the person escorting us would be, we identify potentially a point of operation hazard or whatever it may be, and we would say, what if, could an employee access? What if they would put their hand in there? And a lot of times the immediate response you get back is, well, why would somebody do that? And that's really the mindset you want to get away from. There are a lot of reasons why people could do things. It could be they're trying to clear a jam, they're unfamiliar with the operation, they don't identify the particular hazard as a hazard itself. So you really want to get away from the why would somebody do that and more could they. And if it's yes, they could access that particular point of operation or hazard, then that's something we really need to guard. So we'll talk briefly about machine guarding here. We'll talk about some different guarding options that are out there, hopefully to prevent those amputations. From an OSHA regulatory standpoint, when we're in general industry, we're obviously going to be focused on the 1910 general industry regulations. And we highlighted some of those regulations there. 1912, which is general requirements for all machines. And then there's different standards which get into specifics depending on what the specific piece of equipment is or machine. It may have some specific standards related to it. And then after that, we obviously want to take a look at the 1910-147, which is a Lockout Tagout. In one of the earlier slides there, we took a look at where those machine hazards are present. Obviously the first one was the machine guarding. And then after that, there were a lot of opportunities there to have machine guarding hazards during the servicing and maintenance. which is where your lockout tagout is going to come in. When we're trying to develop solutions to these amputation hazards, we obviously have the OSHA regulations to look at. The downside with some of those are many of them, they're older. They're older standards, and they may not go into a great deal of detail about how we're going to control a hazard. It may say, hey, look, you need to control the hazard, but it wouldn't necessarily tell you how you need to do it or methods to do it. So one of the resources that are out there are voluntary consensus standards. And those such as ANSI, and those are standards that you could use as a guidance to help provide you with solutions to the hazards that would be spelled out in the OSHA regulations. So they're going to give you a little more information, hopefully give you a little more guidance, and potentially some more up-to-date and current guidance. The one thing you want to keep in mind with the national consensus standards are sometimes they may not be as effective or up to the same level of protection offered by an OSHA regulation. So you want to be sure that even though there is some guidance from a consensus standard, it's offering you at least the minimum protection that's required by the OSHA standard. So it's just something to be cognizant of. Just because it may be a recommendation from a voluntary consensus standard doesn't necessarily mean it's going to be compliant. So there are some additional requirements relative to preventing amputations. And some of those pertain to employees that would be on non-farm, non-agricultural jobs where they would be younger than 18. And generally, those employees are prohibited from operating bandsaws, circular saws, shears, punching and shearing machines, meat packing, and then certain other power-driven pieces of equipment. So the concern there is we definitely, with the younger employees, younger than 18 employees, just not to put them into opportunities where they're going to have a higher than normal or higher than acceptable exposure to amputations. So you can see those there. So when we're doing that hazard analysis, what we really want to do is recognize these amputation hazards, and obviously, hopefully, before the event would occur. We want to kind of be proactive with this stuff and recognize these amputation hazards beforehand. So there are a few different things we want to be taking a look at. First, and the most basic, is the point of operation. So that's the area of the machine where the work's actually performed. So we want to focus on the point of operation, see if there would be any amputation hazards there. We obviously have power transmission apparatus such as flywheels, pulleys, belts, chains, anything that's moving where we could potentially have a pinch point, a shear hazard, whatever it may be, or any other moving parts of the equipment. One of the things you additionally want to keep in mind, I had mentioned before, oftentimes when you're doing an analysis, one of the quick responses to a potential hazard would be, why would somebody do that? Another kind of common misconception is we'll take a look at a piece of equipment and point out some machine guarding hazards that ultimately need controlled in some manner. And the business owner or the supervisor, whoever's with you during the survey, would say, well, we just bought this piece of equipment, it's brand new. And you really need to understand that you can buy equipment that is not properly guarded. Even if it's brand new equipment, it doesn't necessarily mean the equipment's properly guarded. And there are a lot of different reasons why that may occur. So just don't assume because you have a new piece of equipment that it doesn't have machine guarding hazards and amputation hazards that need to be controlled. So we have various types of mechanical motions that we're going to be looking for during a hazard analysis. We have rotating motions where we have potential for somebody to be maybe caught in a piece of equipment that's rotating, may create a pinch point. And then there's various ways to control these rotating motions from a guarding standpoint. We have a reciprocating motion, which is a back and forth or up and down motion. And that may cause a hazard, obviously, to the machine operator, but others just in the work area. Transversing motion, which is a straight continuous line that may strike or catch an employee in a pinch or shear point. We have a cutting action. Obviously, this is going to be a lot of your point of operation guarding machine hazards there. We have a punching action, which is caused by a machine trying to hit a ram, slide, and these are obviously result in a lot of point of operation hazards. We have shearing actions. Those hazards occur at the point of operation when the employee typically inserts or holds or withdraws stock by hand. Bending action, you're going to see that in a lot of the common presses and brakes and so forth. Hazard occurs at the point of operation where the employee typically inserts or holds or withdraws the stock by hand. We have in-running nip points. These are very common, especially in your power transmission equipment. So with machine guarding, we have two basic ways that we're going to attempt to eliminate that hazard, that amputation hazard. We have physical barriers and safeguarding devices. So we'll talk briefly about those. Remember, regardless of what method we choose, the goal is to prevent contact with that hazardous area. So what we're really trying to do is prevent access to that machine guarding hazard. And effective guarding is going to, number one, we want to avoid creating additional hazards. So we don't want to implement a control for amputations where we're creating another hazard. We want that to be substantial. So specifically with your physical barrier devices, we want that to be something that's secure, tamper resistant, and durable. Allow for the safe lubrication and maintenance of the machine. So if we can install a machine guard where we can conduct some maintenance and servicing on the equipment without exposing that hazard, that's obviously something we'd want to do, and that alleviates a lot of the hazard. Obviously, it also alleviates some of the opportunities where we'd have to get into our Lockout Tagout program and have authorized employees de-energize and lock out the equipment and so forth. And then we want to avoid with interfering with normal operation of the machine. So that doesn't mean that when we're discussing a potential machine guarding hazard with the operator, a lot of times their immediate response is going to be, well, if I implement that, I'm not going to be able to run the machine. So we may be actually interfering with the way you run the machine currently, but that doesn't mean we can't come up with another method to control the hazard, but still permit the employee to operate the machine. We just sometimes have to think outside the box or involve some new guarding methods into that process. So with the different types of guards we have, the physical barrier guard, which would be the one I mentioned initially there, it's a preferable method because a physical barrier guards can provide less oversight. There's going to be less that's going to go wrong. Some of the times when we get in the other type of guards, we actually were relying on somebody to do something, whether it's a pullback device. They actually have to put the device on. If it's a light curtain, the light curtain has to work. It has to be set up properly. With the physical barrier, there's less opportunity to make an error. And we're not necessarily always going to be relying on somebody to make the correct decision, make the correct choice to make the guard effective. So we have physical barrier devices. And with those can be fixed. And that fixed guard is going to prevent operator from accessing that point of operation to accessing the danger zone. We have barrier guards which are adjustable. You may see some of those on maybe like a power press where it's a fixed guard, but it may be adjustable to accommodate a couple different product lines that may go through that press. We have self-adjusting guards, and this may be a guard that would be similar that you would see on a miter saw, where the guard is going to self-adjust as we operate the saw up and down. The guard's it's going to move independently. And then we have interlocking barriers. So these barriers are going to shut off or disengage power to prevent machine startup when the guard is open, such that you may see on a sliding door on a CNC. So it would be like an interlocking barrier guard. If we open the door, the machine's going to shut off. Some safeguarding devices that are available, and these devices are going to prevent operator contact from the danger zone, would be things such as restraints or pullbacks, two-hand control, a two-hand trip, a synchronized barrier. And we can see on that press right there shown on the picture, that would be an example of a pullback, where once the operator starts that machine cycle, it's physically going to pull their hands back from the danger zone. So the pullback device, like we just discussed there, those are cords connected to the operator's wrist, and they automatically pull the hands out of the point of operation during the cycle. A restraint, they're very similar. There are cords connected to the operator's wrist, but what they're physically going to do is prevent access to the point of operation or that hazard area, where the pullback device may permit access, but when you operate the machine, it physically pulls the hands back. The restraint's going to keep the hands back the entire operation. We have presence sensing devices, such as your light curtains and so forth, which can prevent, if an employee breaks that plane during the equipment operation, it's going to stop the process or return the equipment to a safe state. Then we have pressure sensing mats, which will be interlocked to the machine's control system. You may see these maybe on like robotic welders and so forth, where if I enter the hazard envelope of that piece of equipment's operation and step on the mat, it puts the equipment into a safe state, so it stops the operation. So the various types of safeguarding devices out there. A two-hand control is another example. A two-hand control is going to require you to activate controls with both hands, so keep both hands occupied through the entire operation. Something that's similar to that would be a two-hand trip, where it would enable me to activate the piece of equipment by using two hands. Once I let go of those controls, it'll let the machine continue. The thing you need to remember with the two-hand trip, though, it's going to continue on the cycle. So if that's an option you choose, you have to ensure that they're set up far enough away that if I trip the activation of the machine, I wouldn't have enough time, or the employee wouldn't have enough time to put themselves into a danger zone during the equipment cycle. And then we have type A gates and then type B gates. The type A gates, oftentimes you may see on a mechanical power press, where it's going to prevent access to the danger zone during the completion of during the entire machine cycle. A type B gate, once again, that would be something you may find on a power press, and that's going to prevent access to the danger zone during the downstroke of the press. So just a couple different types, different styles of barrier safeguards with the presses. So obviously for the amputation hazards, machine guarding is a big item, a big area we want to try to control. The other opportunities are, so now what happens when we get into situations where we need to remove the guarding? Well, that's when your lockout tagout is going to come in. So we're doing servicing and maintenance, and maybe the equipment wasn't designed where we can do a lot of that with the machine guarding in place. We're going to have to de-energize and control the equipment while we're exposing the employees to that hazard. So the lockout tagout is going to apply if employees are exposed to the hazardous energy during servicing and maintenance. And then obviously employees may avoid requirements of lockout tagout standard if the machine safeguarding or method eliminates your employee's exposure to the machine danger area during the servicing and maintenance. So the more we can do to design the equipment with proper machine guarding that still permits a lot of that servicing maintenance to take place, that's obviously something we're going to do. We're minimizing our opportunities where we put employees in a position where they have to adequately control the energy to do the servicing and maintenance. With the 1910-147, the Lockout Tagout standard, that's your hazardous energy control program. And that program is going to entail things such as procedures, so your equipment-specific energy control procedures, training, which would be for your authorized employees, so the employees that are authorized to de-energize and control equipment, your affected employees, which would be the employees that could potentially be working in areas where equipment's locked out, and then the awareness level training for just the other employees that may be in the work area. And with that hazardous energy control program, it also requires some auditing. So auditing of your the authorized employee's execution of the procedures, auditing of the procedures themselves. So there are a few different elements there when it comes to the hazardous energy control program, the Lockout Tagout 1910-147. OSHA also has an initiative out for a lot of the employees that may be out there using temporary workers, and that would be as it pertains to Lockout Tagout. And this is something you can look up on the OSHA webpage. It's OSHA 3964. So they have a temporary worker initiative out there specific to Lockout Tagout. If you do have temporary workers in your facility, and especially where they may be operating equipment or involved in some of the maintenance and servicing, this is definitely an initiative that you want to pull up on the webpage and take a look at. Some other amputation hazards would be out there, and a lot of these obviously would pertain to general industry, but they would pertain to construction, retail, trade, service industries also. We have powered and non-powered hand tools such as grinders, shears, bolt cutters, material handling. Oftentimes we'll see amputations where employees are just, they're moving equipment, be it they may be moving a table or just a heavy object, and they don't get a finger or a hand out of the way before they put the material down. It could be through moving equipment with a jib crane, and they find one of their hands in a pinch point. Oftentimes it happens when a piece of equipment, some material just starts to shift, and the initial action would be to try to catch it or stop the item from falling. And it's just a reaction. So it's something where they necessarily wouldn't, put a little thought into it. They're just trying to prevent the material from falling. And then they find their hand or finger into an area where it's a pinch point. And oftentimes it could result in amputations. We have forklifts. So employees trapped or pinned between the forklift, either in the entire body, a body part, whatever it may be, struck or run over, or once again, struck by falling or shifting loads. And then we have doors and covers. So man doors, covers on equipment, where the door or cover would close in a person's hands or fingers in an area where there's potential dangers there. So there's other opportunities for amputation hazards in addition just to your common machine guarding type hazards. There's a lot of resources out there that are available to help you and your business deal with those machine guarding hazards. OSHA has a machine guarding e-tool available on the OSHA webpage, and you can see the link there. So they're going to break down a lot of different pieces of equipment and discuss what the hazards are, what the proper guarding methods are, and so forth. So there's a lot of resources out there to help you control those machine guarding issues you may have. There's also a machine guarding safety and health topic page on the OSHA website, so that's something additionally you can access. With our Pennsylvania OSHA consultation out of IUP, we have a web page that probably many of you are familiar with, and we've also developed a focal point series. The one here shown at the link on this slide is pertaining to machine guarding. We're going to get into a little bit more of the technical machine guarding that may be required for various types of equipment. So you get a little bit more of the detail there about your types of guarding and solutions, so forth. And additionally, there's a focal point series on Lockout Tagout. So what we basically put together there is, maybe 8, 10, 15-minute videos that would go through that information with you, which may be good for anybody can look at that at any point, but definitely for somebody that may be in charge of your facility and helping to develop some of those machine guarding or Lockout Tagout solutions. Just a good tutorial to go through, and obviously it's available on our webpage. So some of the key points, some of the takeaways that we want to remember is amputations are preventable. So sometimes it takes maybe reanalyzing how we're operating the piece of equipment. Are we using the right piece of equipment to complete the operation? But there's always going to be a solution to prevent the amputation injuries, whether it's a guarding issue, a physical guard, some other type of guard. There's always going to be a solution. So we can prevent all these amputation hazards. Get away from the idea of why would somebody do that or why would somebody access that hazard, and think more along the lines of could they? And if the answer to the could they is yes, we want to come up with a potential solution for that. So there are options out there. Just because a machine's new doesn't mean it's sufficiently guarded. And then another thing we want to remember are the temporary workers. So as we're bringing temps in, what potential hazards are we exposing them to? Do we have our machines guarded properly? Are we considering what they may be doing from a servicing and maintenance standpoint to ensure they're properly trained and equipped to do those operations? There's we mentioned some of the resources that are out there earlier. Here's some other additional resources and references, so you can see all these on the page here. There's just a lot of tools out there. No matter what the machine guarding hazard is, there's going to be a way to control it, and there are some resources here to help you define what those are. If you do have some machine guarding questions or issues, be it for your entire facility or a particular machine, you can always contact us as well. Through the IUP, Pennsylvania OSHA Consultation Program. We can come out and do a machine guarding audit for you, be it the entire site or a particular piece of equipment, like we mentioned earlier. So if it's something that's kind of beyond your knowledge, your scope of understanding, we're always a resource for that. So give us a call, go online, put a request in, and we'll definitely come out and give you a hand. Just to provide you a little bit more information on our OSHA consultation program. With PA OSHA consultation, it's a free service designed specifically for small and medium-sized businesses. And what OSHA considers a small business would be less than 500 employees at a corporate level, less than 250 at a site. The vast majority of businesses we visit are going to be well below that 250 at a site, probably maybe 5, 10, 15 employees at a site. So don't think they're too small, obviously, to reach out to get some assistance. We'll give priority to employers in high hazard industries involved in hazardous operations. And obviously with the emphasis on amputations currently, the businesses that would have some of those machine guarding issues would be included in that. So we would be trying to give you some higher priority, even with our backlog, to come out and give you some assistance with that. The businesses that are larger, they can still put requests in as well. It may take us a little bit longer to get to you, or we may have to do the visit on a limited scope. So it may not be a full service where we're looking at everything, but more limited to where it's a particular discipline or maybe a particular piece of equipment or whatever it is. With our service, where we're different from OSHA enforcement is we don't issue citations, penalties, violations, anything like that. However, you have to agree to correct any serious or imminent danger hazards. So generally, if we help you to identify one of those hazards that's included in our scope, we'll identify what the hazard is, identify the OSHA regulation, give you some recommendations to correct it. But then you ultimately have to correct it. Generally, we go out 60 days for that, and then we work with you and help you obviously come up with that correction. One of the benefits are if you use our service to help identify the hazard, and it's a serious hazard, and you're working on the correction, as long as we have an interim protection plan, corrective action in place, something we can do while you're working on your ultimate correction, you'd be exempt from the program OSHA inspection. So you're being proactive. We've identified a hazard. We've come up with some interim protective measures, and then while you're working on your ultimate correction, be it a machine guarding initiative or whatever it is, you can't be inspected from OSHA enforcement for that. Kind of the give back there is you do have to correct it, and if somebody doesn't correct a serious hazard, we'd have to refer them to OSHA enforcement. But within the 6 years I've been with the program, I don't know of that ever occurring. So that'd be very rare that we'd have to refer somebody to enforcement that's voluntarily trying to correct a hazard that we're helping them identify and correct. So it'd be very rare that would happen. So some other benefits of the service. Obviously, it's a free service. The ultimate goal would be obviously to avoid those hazardous situations where maybe potentially exposing an employee to an amputation or whatever the hazard may be, helping the employee and employer avoid those OSHA penalties and litigation costs, reduce workers' compensation costs, minimize equipment damage and product loss, and then just as a side note there, on average, consultants will identify 7 serious and other serious hazards. And the direct savings there for just from OSHA citations would potentially, be $87,000 or so. But that would just be the direct cost of the violation. You're not really considering the indirect cost, which would be the cost of replacing the worker, the cost of the injury itself. So there's a lot of cost saving benefits to trying to identify and control the hazards. If you'd like to contact us, you can see our phone number there. There's our website. We also do Facebook and Twitter. You could put a request in via telephone or just go on the website. You'll see a request form there. If you go ahead and submit that, put your information in, hit submit, and then one of our office staff will get back to you, let you know who your request has been assigned to. You can identify on that screen specifically if there's a particular topic you're interested in or whatever you feel you'd want to enter there. Like I said, we'll submit the request. You'll get notification on who your consultants assigned are, and then we'll go from there. So, thanks for participating, everybody. We'll be doing another webinar on heat-related illnesses on April 17th at 10:30. So you can see our information there below once again, and just thank everybody for participating. And obviously, if you have any questions, give us a call, send us an email. Put a request in, and we'll get a hold of you. Thanks a lot.